So problem 4 is asking us about a hydraulic system which is kept with both sides at equal height, with one side having a 1,000 kilogram mass and the other side having some force F that's being pushed to keep the system at that equal height. So the area of the left-hand force is given us as 50 centimeters squared, with the area of the right-hand force given as 1.0 meters squared. So one of the first things I went ahead and did, you can see on the right, is convert that 50 centimeters squared to meters. And this part can be kind of tricky because you have to remember anytime a unit is squared, you have to convert it. Like, the conversion factor also needs to be squared. So that's why you can see A1 becomes so much smaller than you might expect when you're converting from centimeters to meters. So next is essentially just figuring out how to solve the problem. Using Pascal's principle, which is based off of the fact that in a fluid system like this, pressure is equal everywhere. That means that the pressure on the side with the smaller area is equal to the pressure on the other side. So P1 equals P2 when the heights are equal. We can use the fact that pressure equals force over area to then say that the force F1 over A1 equals F2 over A2. So those two sides are going to be equal. And the only thing that we don't know yet of this is, of course, F1, because that's what we're solving for by the end of the problem. But we also need to solve for F2, but that's going to be pretty easy, and you'll see that coming up next. Okay, so you can see that F2 is just mg, and we're given the mass equals 1,000 kilograms, so you just multiply that by 9.8, which is g, giving us that it's F2 is 9,800 newtons. So all we have left to do is just plug in the numbers that are appropriate for the situation, giving us a final answer of 49 newtons is the force that you are going to want to apply on that left side to balance the 1,000 kilogram weight. So that is the answer to the problem. For me, the tricky thing was once I got my answer, it's kind of hard sometimes to comprehend how much bigger F2 is going to be as compared to F1. Especially the problem even notes that the drawing is very not to scale. So sometimes you might find your answer and feel like it's unreasonable. But this principle, which basically implies that a smaller area means that you have to apply a smaller force, really does hold true. So, yeah, that's basically the end of the problem. Thank you for listening.